Imagine you've got raw customer records sitting in an S3 bucket, and you want to start building your data pipelines. But before you can process anything, you need a way to organize and describe that data so AWS services know how to work with it. That's where AWS Glue databases, tables, and crawlers come in. Hi, I'm Professor Reza's AI avatar, and in this video, we'll walk through how to create a metadata database in Glue and set up tables in two ways: manually defining the schema and using a crawler to automatically discover it from your data sources. By the end of this video, you'll understand how to create and manage Glue tables, when to use a crawler, and how it simplifies the whole process of making your data usable. Let's get started. We can add a database by just clicking on Add Database. Let's give this database a name. I'm going to name it Raw Data. Next, we can add a description. I'm just going to write, "This database contains the raw data for our project." We can also add a location. This is optional, but it's best practice that you do it. We can just go into S3, open up a new tab, click on our S3 bucket. Mine is named Profreza Glue Course S3 bucket. And for our raw data, get the S3 URL and paste it as your database location. Then we click on Create Database. Here we have our database. As we mentioned in the previous video, the data itself is not stored here. The data itself is in our S3 bucket. This dataset is actually a metadata database, meaning that it only points to where the information can be found. All right, now that we created our database, let's talk about tables. And yes, you guessed right. Tables in AWS Glue are metadata tables. They describe the structure of our actual data. They contain information like column names, data types, the file format in S3, or the type of storage, serialization, compression format if we have it, and partition keys if we partitioned it. Tables are generally important because they're what ETL jobs use to know how to read and process our data. They're also used for other AWS services like Athena to create your data directly. Using a crawler is usually easier, especially for simple datasets. Manual definition works fine for small, clean datasets. But if you're dealing with messy or complex data, crawlers are much better. Speaking from experience, it can take dozens of hours to define a complex table manually. If your data is complicated, you can also use a mixed approach. Start with a crawler to generate the table, then edit it yourself based on what you think works best. But let's take a step back and see what a crawler is. A crawler is basically an automated service that scans the data sources we have, detects the schema and format of our data, and it creates metadata tables in our data catalog. It can automatically detect formats like CSV and JSON, along with column names, data types, compression types, and partitioning schemes. Crawlers can then create or update tables in the Glue database accordingly. We typically use them when dealing with many datasets, when the data structure might change over time, or when we're unsure about the structure and want the metadata to stay in sync with the actual data. When you run a crawler, it connects to our data source, scans the data to determine some form of structure, and then it creates new tables or updates the existing ones. These tables are then used by ETL jobs and other AWS services. When you're setting up crawlers, usually you want to schedule them to run periodically to keep your tables and datasets up to date. We will go over this in the next videos when we set up a Lambda function. Now, we're going to see how to create tables both manually and using crawlers with the sample data we have. The first thing we need to do is to set up some tables. We can do that by going on the left sidebar and clicking on Tables. You can see that we don't have any tables right now. we can either manually create a table or create one using a crawler. For the purposes of this tutorial, we're going to show both of them. Click on Add Tables and enter a unique name. Now, the first table that we're going to create manually is customers, and then we're going to do orders using a crawler. So let's call it customers, and we need to select which database we want this to belong to. Let's pick raw data. For the table format, let's just pick standard. Data source is going to be S3, and the data is located in my account. We can go ahead and include a path. Click on Browse S3, and then we can click on our bucket. From there, click on Raw Data, select Customers, and click on Choose. And now you can see that the path to our S3 bucket is included. Our data is in the CSV format, so we're just going to click on that and click Next. Now, for this table, we want to define the schema for our table by clicking on Add. We have the column number in here, and we have the data type of each column located in here. If we look at the table we have in our GitHub repository, we have customer ID, first name, last name, and full name. For customer ID, the type is integer. So for the name, we type customer ID. And for the data type, we'll select integer and click Save. This is going to make sure our first column is called customer ID, and all the data in it is of data type integer. We're going to do the same thing for first name, last name, and full name. All of these are strings, so we don't need to change the data type. Once we've added them, we can click Next, review the schema, and then click Create. And we have our table created. We can check it out by going to Tables. We can see Statistics, Data Quality, and we have Table Data. Now, we're going to go in and create a table using a crawler. So you can just go into Crawler and click on Create Crawler. For this one, we're going to be using the Orders table. So let's just name it Orders. For the description, we can enter anything we like. It's optional, but for example, we could say, this is a table for orders, and we can just click on Next. Here, we want to add a data source, so let's click on it. Our data source is S3. We're not going to be using a network connection. The location is going to be in this account, and to pick the S3 path, we click on Browse S3 and select the S3 bucket for this tutorial. Click on Raw Data and select Orders. This is the table that we want to crawler to crawl through. Make sure you select Crawl All Subfolders so it checks everything inside it. And click on Add an S3 data source. Click Next. Now we are in step 3. Choose your IAM role. We don't need to use the lake formation, so let's just skip it. Click Next. In step 4, we pick our target database. Under Maximum Table Threshold, we can configure the crawler to run on demand, hourly, daily, or weekly. For now, we'll set it to on demand. Later, when we integrate with Lambda, we can trigger the crawler automatically. For example, by running a function whenever there's a change in the data. Click Next. And we have everything in here in step 5, Review and Create. Make sure everything looks right and then just click on Create a Crawler. It's going to run, crawl through our data, and automatically create a table. I'm going to stop the video here, and once it's done, we'll come back and see what was created. Okay, as you can see, our crawler has successfully crawled through the data and created the table. We can go into Tables and view it. If you don't see the new table, click Refresh. and you'll see that the orders table has been created. It's essentially created the same way as the customers table, but automatically. Without a crawler, we would have had to manually define all of these columns ourselves, which is a lot of work. So now we have our dataset and tables set up. Now you've seen how to create tables in AWS Glue, both manually and using a crawler. Crawlers are powerful tools that save you time and help keep your metadata in sync with your actual data, especially when things get complex. In the next video, we'll cover one of the most important parts of AWS Glue, the ETL job. We'll explain what an AWS Glue ETL job is, how it works, and how you can use it to transform and manage your data.